Today, Homo sapiens dominate the Earth with more than 8 billion individuals. But few people know that there was a time when modern humans almost vanished, leaving only a few thousand survivors, standing on the brink of extinction. If that event had been more catastrophic, perhaps you and I would not exist today. Around 300,000 years ago in vast Africa, a new human species emerged. That was Homo sapiens, the wise human. Compared to earlier human species such as Homo erectus or Homo habilis, Homo sapiens had one special trait. Their brain was far more advanced, with a higher forehead, a more refined face, and most importantly, the ability for abstract thinking. This very difference opened the path for modern humans to become the rulers of the planet. At first, Homo sapiens were only small groups wandering across the African savannas and jungles. They lived by hunting and gathering, entirely dependent on nature. Men hunted antelopes, giraffes, and even baby elephants, while women and children gathered fruits, dug up roots, and collected wild seeds. They knew how to use fire, craft tools from stone and bone, gaining a crucial advantage in a harsh life. Around 200,000 to 100,000 years ago, the first groups of Homo sapiens began leaving Africa. They crossed deserts, followed coastlines, and gradually spread into the Middle East and later into Asia. On that journey, they encountered their other relatives, Neanderthals in Europe and West Asia, Denisovans in Siberia. For centuries, these human species coexisted, sometimes competing, sometimes intermingling. DNA evidence today shows that inside each of us lies a portion of Neanderthal or Denisovan genes, remnants of those ancient unions. The life of Homo sapiens at that time was anything but easy. They had no agriculture, no cities, no writing. Everything revolved around survival, finding food, seeking shelter, and avoiding predators. Small groups, often only a few dozen individuals, moved constantly with the seasons, relying on memory and natural signs to navigate. Language then was still primitive. Sounds, gestures, and symbols used to coordinate hunts or warn of danger. Yet even so, it was a tremendous advantage over most other species. In Africa and elsewhere, the climate remained relatively stable for tens of thousands of years, allowing Homo sapiens to thrive. They expanded their range, adapting to many environments, from dense jungles and arid savannas to fish-rich coasts. From Africa, they spread across the Eurasian continent, preparing for a journey to conquer the world. Homo sapiens seemed to be in their first golden age, a small species but brimming with potential. However, what they did not know was that Earth itself was preparing the harshest survival test. Around 74,000 years ago, when Homo sapiens had only just scattered into small groups across the planet, a devastating natural disaster suddenly struck. A supervolcano on the island of Sumatra, named Toba, erupted, releasing thousands of cubic miles of lava and ash into the atmosphere. This was one of the largest eruptions in Earth's history. Ash from Toba spread across Asia, covering the skies and blocking sunlight. Global temperatures dropped sharply, plants died en masse, and food chains collapsed. Both humans and animals had to face a volcanic winter lasting for years, even decades. And in that context, Homo sapiens, a species that seemed to be rising strongly, suddenly became more fragile than ever. Before the disaster, Homo sapiens were a species full of potential but not yet truly secure. They were only in the early stages of evolution, not numerous enough to spread everywhere, not strong enough to control nature. Then a terrifying event occurred, one that nearly wiped out all modern humans. It was the eruption of the Toba supervolcano, located on the island of Sumatra in present-day Indonesia. If you think of a volcano, you probably picture glowing red lava flowing from the crater and ash covering the sky. But Toba was not an ordinary volcano. It was a supervolcano, a type of volcano with destructive power thousands of times greater than even the largest volcanoes today. When Toba erupted, it spewed out about 2,800 to 3,000 cubic miles of lava and ash, an unimaginably massive volume. To put it into perspective, this eruption was 5,000 times more powerful than the eruption of Mount St. Helens in the United States in 1980, and it far surpassed even the Krakatoa disaster of 1883, once recorded as cataclysmic. The explosion's power was enough to completely destroy the surrounding environment. Layers of ash several yards thick blanketed all of Southeast Asia. Pyroclastic flows, superheated gas mixed with lava, rushed down at speeds of hundreds of miles per hour, incinerating every living thing in their path. Lakes, rivers, and jungles around Sumatra turned into a sea of fire in moments. Yet the impact of Toba did not stop at the local scale. Billions of tons of ash and sulfur gases were thrust into the stratosphere, spreading across the entire planet. The atmosphere grew murky, sunlight was blocked, leading to a phenomenon known as volcanic winter. Global temperatures suddenly dropped by 5 to 9 degrees Fahrenheit, and in some places, even lower. The freezing winters dragged on not just for a few years, but possibly for decades. For ecosystems, this was a death blow. Plants could no longer photosynthesize, and vegetation died off on a massive scale. Herbivores lost their food sources, triggering the collapse of the entire food chain. Many large animals disappeared from regions of Asia and Africa. For Homo sapiens, who depended on hunting and gathering, this was a survival catastrophe. Imagine this. From hundreds of thousands of Homo sapiens scattered across Africa and Asia, after the Toba supervolcano eruption, the population of modern humans plummeted dramatically. Small groups of people were completely wiped out, while once thriving communities dwindled to only a few survivors. This was the stage known as the genetic bottleneck, a concept in evolutionary biology describing a drastic reduction in population size, leading to a major loss of genetic diversity. Evidence for this bottleneck comes from our very own DNA today. When scientists decoded the human genome, they discovered that the genetic diversity of Homo sapiens is unusually low. Compared to chimpanzees or gorillas, our close relatives, the genetic difference between any two humans on Earth is far smaller than the difference between two individuals of those primates. This could only have happened if our ancestors once went through a period of extremely low numbers, causing the shared gene pool to shrink severely. According to many estimates, at that time the global population of Homo sapiens may have dropped to only 2,000 to 10,000 individuals. That number is equivalent to a small town today. If we gathered all the surviving ancestors back then into one place, they would just about fill a soccer stadium. That fragility is almost unbelievable. A single epidemic, a drought, or another natural disaster could have easily erased the entire human species. So what are the consequences of a genetic bottleneck? When there are too few individuals, many rare genetic variants disappear forever. The impoverished gene pool makes the species more vulnerable to diseases or environmental changes. In fact, this decline has left its mark even to the present day. Some scientists believe that common genetic diseases in modern humans, from hemophilia to immune disorders, may trace back to that harsh period when dominant and recessive genes were concentrated within a tiny community. But the paradox here is this: the genetic bottleneck actually contributed to the unity of Homo sapiens. When only a few thousand people survived, they shared the same genetic foundation. This explains why humans around the world, from Africa, Europe, and Asia to the Americas, all share such a remarkable similarity in DNA. Scientifically speaking, any two people on the planet may differ in language, culture, or skin color, but genetically, they are far closer to one another than individuals in many other animal species. Many anthropologists argue that the bottleneck stage became a crucial survival test. Only those groups that were the most adaptable, the most cooperative, and the most creative could endure. Small groups that learned to exploit coastal seafood, craft more sophisticated tools, or organize more efficient hunts became the nucleus for the revival of Homo sapiens. One could say that intelligence and cooperation were the weapons that helped humanity pass through the narrow gate of life and death. Astonishingly, from just a few thousand individuals, Homo sapiens not only survived but recovered, grew, and eventually spread across the planet. So how were they able to pass such a harsh test? While many animal species vanished, and even other human species like Homo erectus or Homo floresiensis gradually went extinct, Homo sapiens rose with strength. What was the secret? First and foremost, the power of community cooperation. At the most difficult moment, Homo sapiens understood that individual existence mattered less than the survival of the group. Small communities, usually around 20 to 50 people, divided roles. Men hunted, women gathered, elders cared for children, and young adults protected the group from predators. Without this cooperation, lone individuals would have quickly perished from hunger, disease, or enemies. Archaeological evidence shows that as early as 100,000 years ago, Homo sapiens already displayed signs of burying the dead and caring for the sick. This proves that they cared for one another more than any other human species. It was precisely compassion and social bonding that turned them into resilient groups, capable of enduring even the darkest times. In a harsh world, intelligence became the strongest weapon. Homo sapiens crafted stone tools far more sophisticated than earlier human species. Spear tips with sharp stone points, blades made from quartz or obsidian, volcanic glass, allowed them to hunt large prey, from deer and wild horses to even young mammoths. More importantly, they mastered fire. With fire, they could cook food, kill bacteria, digest more easily, and absorb more energy from the same amount of nourishment. This energy fueled their large brains, which consumed many calories and fostered intellectual growth. Fire was also a shield against darkness, a defense against predators, and a source of warmth during the freezing volcanic winters. One could say that fire transformed Homo sapiens into true humans, setting them apart from all other primates. While land ecosystems collapsed, many groups of Homo sapiens sought refuge along the coasts. Archaeological studies at Blombos Cave and Pinnacle Point in South Africa show that around 70,000 to 80,000 years ago, humans were already exploiting marine resources, from fish, clams, and snails to seaweed. This was a rich, nutritious food source, abundant and less affected by global climate change. These coastal oases may have served as the final refugees where a few thousand Homo sapiens endured the volcanic winter. From those small seaside communities, the human population gradually recovered. The DNA of many people today carries traces indicating that our ancestors descended from groups that survived in East South Africa and along the Indian Ocean coasts. Another crucial factor that helped Homo sapiens survive the crisis was early language. Though not as complex as modern speech, humans back then could already produce systems of sounds, symbols, and gestures to coordinate hunts, warn of danger, and share knowledge. When one group discovered a better way to make tools, they could pass it on to another group. When a hunting ground ran out of food, they could inform others to search elsewhere. This was a capability that Neanderthals, though strong and intelligent, may not have reached at the same level. Thanks to language, Homo sapiens not only survived, but also passed down experiences across generations, giving each new generation a higher starting point than the last. Homo sapiens were also the most versatile of all human species. They could live in jungles, grasslands, caves, or along the coast. When large animals disappeared, they switched to hunting rabbits, birds, and fish. When trees died in the cold climate, they dug up underground tubers and relied on stored nuts and dried fruits. This flexibility set them entirely apart from many other species, which depended solely on a single food source. For example, if an animal species survived only on tall grasses, it would go extinct once the grasslands vanished. But Homo sapiens could pivot, find alternatives, and keep adapting endlessly to survive. Thanks to all these factors, cooperation, tools, fire, coastal seafood, language, and adaptability, Homo sapiens passed through history's narrow gate. From just a few thousand individuals, they gradually recovered, then expanded out of Africa, into the Middle East, Asia, Europe, and eventually across the globe. Along the way, Homo sapiens met, interbred with, and eventually replaced other human species such as the Neanderthals and Denisovans. Although fragments of those species' DNA still remain within us, only Homo sapiens survive to this day. Looking back, the survival of Homo sapiens was never guaranteed. It was the result of intelligence, unity, and resilience in the face of adversity. Had our ancestors been weaker, less creative, or unwilling to cooperate, Homo sapiens might have vanished like so many other species. And today, you and I would not be here to tell this story. For decades, the Toba catastrophe hypothesis and the genetic bottleneck have been among the most fascinating stories of the Homo sapiens past. However, as science advanced, researchers began to argue fiercely. Was the Toba event truly that destructive, or have we exaggerated it? In the 1990s, geneticists published analyses of modern human DNA. Our genetic diversity is unusually low, suggesting that at some point the human population dropped to only a few thousand individuals. This became the basis for the Toba bottleneck hypothesis. According to this idea, the eruption 74,000 years ago triggered a volcanic winter lasting for decades. Sunlight was blocked, global climate cooled by 5 to 9 degrees Fahrenheit, plants died off in huge numbers, and food chains collapsed. Homo sapiens, who were in the process of expanding out of Africa, suddenly fell into a survival crisis. Many small groups were wiped out, leaving only a few thousand lucky survivors in coastal survival oases. This dramatic scenario spread rapidly through both science and the media. It led people to imagine that all of humanity today descends from one tiny band of ancestors who passed through history's narrow gate. However, from the early 21st century onward, a series of archaeological studies raised doubts. Scientists excavated the Jwalapuram site in southern India, a place directly affected by Toba's ash fallout. They discovered that stone tools crafted by Homo sapiens appeared continuously before and after the catastrophe, with no signs of interruption. This suggested that humans survived the eruption without being wiped out. In Africa, coastal caves such as Blombos Cave also showed evidence that Homo sapiens maintained their presence after the time of Toba. There is no clear proof that the human population plummeted as catastrophically as the few thousand survivors scenario suggests. Some climatologists even argue that Toba's global impact has been overstated. While ash spread widely, the atmosphere may have been able to recover more quickly than we assumed. Temperatures may have dropped sharply in some regions, while coastal areas or places near the equator retained relatively stable living conditions. This could explain why certain communities of Homo sapiens not only survived but continued to develop. Even if we accept that humanity experienced a genetic bottleneck, it does not mean Toba was the sole cause. Some scientists argue that the founder effect is a more plausible explanation. When a small group of Homo sapiens left Africa to migrate into the wider world, they carried with them only a fraction of the species' total gene pool. The global spread of this small group explains today's low human genetic diversity, without requiring a worldwide catastrophe as the sole cause. Moreover, throughout evolutionary history, Homo sapiens and other human species may have gone through multiple population declines due to climate shifts, disease, or conflict. Toba was only one of these major events, not necessarily the sole cause of the genetic bottleneck. In reality, the truth may lie somewhere in between. It is possible that Toba had a strong impact in certain regions, wiping out many Homo sapiens groups. But in coastal areas or regions less affected, humans held on. As a result, even though they were not driven extinct, Homo sapiens still endured a significant population decline, and the genetic traces of that period remain within our bodies today. What is certain is this: Toba did not wipe out Homo sapiens. Archaeological evidence shows that humans continued to create tools, paint on cave walls, and craft jewelry from seashells, symbolic behaviors proving that human intelligence did not fade after the disaster. If anything, the harsh adversity forged Homo sapiens into a species stronger, more united, and more creative. Whether or not Toba truly brought Homo sapiens to the brink of extinction, the story of the genetic bottleneck still carries great meaning. It reminds us that human existence has always been fragile against nature. A supervolcano, an asteroid, or climate change could all become survival tests. At the same time, the debate shows that science is ever evolving. Each new piece of evidence, from ancient DNA to archaeological remains, sheds more light on the puzzle of evolution. The truth may never be simple, but the search for it is what makes the story of Homo sapiens all the more compelling. More than 70,000 years ago, Homo sapiens nearly went extinct after the Toba catastrophe. And even in modern times, countless threats could push humanity into a new bottleneck, or even wipe us out entirely. Earth still harbors dangers powerful enough to thrust humanity back into a genetic bottleneck. A supervolcano like Yellowstone would need to erupt at only a fraction of Toba's scale to collapse global agriculture, leaving billions facing famine. Climate change, this time caused by human hands, is melting ice, raising sea levels, and driving extreme weather. It could become a man-made Toba disaster, slower but no less destructive. Beyond that, humanity also faces the threat of nuclear war. A full-scale conflict would not only kill hundreds of millions, but also unleash a nuclear winter, spreading radioactive dust into the atmosphere and devastating crops, just like the Toba scenario. Global pandemics are another threat. In today's interconnected world, a novel virus could spread faster than anything in history. And finally, dangers from outer space, asteroids, always loom, just as one once wiped out the dinosaurs. The difference between now and the past is this. Our Homo sapiens ancestors survived only through cooperation and adaptation, whereas we also possess knowledge and technology. But technology is both a shield of protection and a potential cause of destruction. Will Homo sapiens use it to overcome threats or to bring about their own downfall? The answer remains uncertain. But one thing is sure, just as 74,000 years ago, the fate of humanity still depends on our unity, intelligence, and adaptability.